Imagine stepping into a massive silver rocket unlike anything you've ever seen before. Towering high above the launch pad, it gleams like a spaceship from the future. This is the SpaceX Starship, not just a powerful rocket, but humanity's most serious shot yet at making the leap from Earth to Mars. But behind all the hype, glamour, and sleek sci-fi design lies a harsh truth. Traveling to another planet won't be anything like a luxury cruise. It'll be long, cramped, dangerous, and, let's be honest, a little disgusting. So what will it actually be like for the first humans to ride the Starship all the way to the Red Planet? The original concept for Starship was almost utopian. SpaceX envisioned the entire upper half of the 50-meter-tall rocket as a sprawling open area, shared between cargo and crew. Think huge panoramic windows, open concept decks, and a spacious, futuristic vibe with around 1,000 cubic meters of room. It looked like the sci-fi dream coming true. But dreams tend to change once they crash into reality, literally. When SpaceX started flying Starship prototypes and trying to land them, things didn't exactly go smoothly at first. Rockets exploded, metal crumpled, and landing attempts became viral memes. Through this crash course in trial and error, engineers made some big design changes. One of the most significant adjustments involved relocating the secondary fuel tanks used for the rocket's landing burn. Originally located near the base, they were shifted into the nose cone. Why? Because as the rocket performs that signature flip maneuver during descent, the base swings around dramatically, creating instability. By moving the tanks to the top, SpaceX made landings more stable and reliable. But that also meant the pointy tip of the rocket, once imagined as a prime crew zone with big beautiful windows, was now filled with fuel tanks. No more luxury observation deck. Then came the real orbital flights. As Starship finally made its way into space and back again, the need for more fuel and stronger performance drove further changes. In 2025, SpaceX rolled out the Starship V2. On the outside, it looks more powerful and is about 2 meters taller than its predecessors. But inside, it's actually smaller. SpaceX decided to extend the fuel tanks upward, deeper into the payload area. This increased the ship's propellant capacity, allowing it to carry itself and an additional 100 metric tons of cargo to low Earth orbit. That's a massive step forward for mission capability, but it comes at the cost of habitable volume. Instead of 1,000 cubic meters, we now have about 500 cubic meters of usable interior space. Now, that might still sound roomy, and in many ways it is. For comparison, the International Space Station offers around 900 cubic meters of internal volume, but it's arranged in a tight maze of narrow tunnels and compartments. Despite the cramped conditions, the ISS regularly supports a crew of 7 and has hosted up to 13 astronauts at once. So, how many people could reasonably ride a Starship V2 to Mars for a 2.5-year round trip? NASA actually tackled this question back in 2013. Their study concluded that for a Mars mission of that length, each astronaut would need at least 25 cubic meters of shared space. That's not private quarters, just general space per person to eat, sleep, work, and breathe without going stir-crazy. With that metric, Starship V2 could technically house up to 20 astronauts. But let's pump the brakes. That figure doesn't consider all the necessities of life in deep space. A ship built for humans can't just be a giant empty tank. You need structural elements like floors, walls, and a central shaft with ladders for moving between levels. You'll also have to devote a huge chunk of space to life support systems, food and water storage, waste recycling, medical supplies, and more. And the lower level? That will be reserved for the airlock and cargo bay. If you're lucky, you might have room for about 6 crew members. That's a far cry from the colonizing vision of Starship, and definitely not a scalable plan for Mars settlement. That's where Starship V3 enters the picture. Often called the Long Starship, V3 stretches the rocket to 69 meters tall, a full 17 meters longer than the V2. That extra length might seem like a game changer for interior volume, but it's not that simple. More size means more mass, which requires even more propellant. So a big chunk of the added space is immediately eaten up by larger fuel tanks. Still, V3 manages to claw back a good deal of the original vision. With clever design tweaks, the habitable volume goes back up to around 1,000 cubic meters. So, after all the back and forth, SpaceX ends up delivering on their early promise, just with a few detours along the way. That's engineering for you, full of compromises but always moving forward. Now that we've established our floating Mars habitat, it's time to dig into the details of what life aboard Starship will really be like. Let's start at the bottom. Level 1 is where the cargo bay and airlock will be located. This isn't just a storage space, it's a functional area for astronauts to prepare for EVA, extravehicular activity, especially on Mars. We already have a great reference for this setup thanks to the Artemis program, where a modified Starship will be used to land humans on the Moon. In that version, the lower level features a circular airlock with EVA suits arranged around the inside perimeter. When it's time for a mission, astronauts suit up, move through the airlock and enter the cargo bay. The cargo hold will house all the critical gear for Martian exploration: rovers, scientific instruments, sample containers, habitat construction tools, solar panels, and more. And to get all this heavy gear down to the Martian surface? An elevator. Given that Starship sits high off the ground, SpaceX has shown a prototype lift mechanism that resembles a mix between an old industrial elevator and a shark cage. It's not fancy, but in space, reliability beats style any day. Now let's move up to level 2. This is where we expect to see the first dedicated pressurized storage area. From a design perspective, it makes sense to keep heavier materials closer to the base to maintain a low center of gravity, crucial for a ship that will land vertically on another planet. This level would be perfect for storing food, water, backup supplies, emergency equipment, and perhaps some bulkier components like spare batteries or repair kits. But beyond logistics, this level will also likely serve as the foundation for building out livable space above. Every level added must account for human needs: air circulation, temperature control, radiation shielding, and artificial gravity, if we ever figure that out in a cost-effective way. If you've ever seen the inside of the ISS, you'll know how tightly packed these systems can be. So by now, we've only covered the first 2 levels of Starship's interior, and already a significant chunk of that 1,000 cubic meters is spoken for. That's the reality of designing spacecraft. Every cubic meter must work overtime. In the next part, we'll journey higher into the ship to explore living quarters, hygiene facilities, medical bays, dining areas, and communal spaces. Because if we're going to spend years together floating through the void to another planet, we better make it as bearable as possible. But one thing is already clear: SpaceX's Starship in all its evolving forms isn't just a rocket. It's a proving ground for what life beyond Earth might really look like. And it's not about being easy or glamorous. It's about being possible. Now let's continue upward through the Starship. The second deck is going to serve as a kind of utility zone. That's where we'll handle all the core life support systems. Think of it like the guts of the ship. This is where our water purification system, oxygen supply, HVAC, food storage, and waste management units are housed. Basically, everything that keeps us alive and functioning is crammed into this floor. It's highly practical and purpose-built. Without this level running perfectly, it doesn't matter how comfortable the rest of the ship is. None of it would matter if we can't breathe, eat, or stay warm. Heading up to Deck 3, logic tells us we should keep the hygiene area close to the storage systems. Why? Because the shorter the plumbing, the better. Less complexity means fewer chances for breakdowns. So the showers, sinks, and toilets are likely placed here. But don't expect luxury. There will be no rainfall showers or bubble baths. Far from it. Hygiene on the way to Mars means sponge baths with a damp cloth, maybe some dry shampoo, and a very real understanding that water is a precious, recycled commodity that you won't be wasting. Things get especially intense when it comes to wastewater management. It's not glamorous, but it's critical. Without a recycling system, we'd need to haul about 27 metric tons of water just for a crew of 10 people on a 900-day mission. That would eat up a huge chunk of the Starship's total lifting capacity, somewhere between 1/4 and 1/8 of what it can carry. But with advanced recycling technology, we can slash that requirement down to only 3 metric tons. That's a massive reduction, and it's the only way a mission of this duration is even remotely practical. The International Space Station already recycles 93% of its water. That means everything, including urine, is filtered and reused. Even solid waste gets handled efficiently. It's dehydrated and compacted, with the extracted moisture also fed back into the water system. It's not glamorous, but it's efficient. So yes, astronauts really do drink purified versions of their own urine. It's just part of the deal. Anyone signing up for a Mars mission has to accept this as their new reality. This is the cost of pushing humanity into deep space. No room for squeamishness, just engineering excellence. Reportedly, SpaceX is already thinking ahead. People who've seen the mock-ups of the lunar starships say they're designing rectangular hygiene pods. These would double as a toilet and shower station, built to fit along the curved inner edge of the spacecraft. That way, the available space is used as efficiently as possible. With these pods arranged neatly, there should be just enough room to squeeze in a gym on the same floor. This isn't just about fitness, it's medical. Everyone will need at least 2 hours of physical activity a day just to prevent muscle atrophy and bone loss. Exercise in zero gravity is its own challenge. Traditional workouts won't cut it. So astronauts will be equipped with resistance machines, stationary bikes, and treadmills, all with tie-down systems to keep them in place. These machines are already standard aboard the ISS, so SpaceX will likely build on that experience. Cardio and strength training aren't just optional, they're essential. It's not about getting ripped for beach season. It's about making sure you can still walk once you get to Mars. And having the gym share a floor with hygiene facilities helps contain both the smells and the sweat. Moving up to Deck 4, we're now in the heart of the crew quarters. This space is going to depend heavily on how many people are making the journey. If we began with a raw internal volume of about 1,000 cubic meters, and we use up 2 decks for life support and storage, we're probably left with around 600 cubic meters for living space. That may sound vague, but to put it in more relatable terms, it's about the size of a big house. Think 3 or 4 bedrooms and roughly 2,300 square feet of total floor space. That's more space than most people would expect on a spacecraft. It sounds decent enough for a family, but this is a crew of highly trained professionals living together for almost 3 years. According to NASA's own guidelines, that amount of space is suitable for up to 24 people without psychological stress becoming a serious risk. And that actually matches what we've heard about SpaceX's Starship moon lander. Reports suggest that they're designing rectangular sleep pods, kind of like compact bunk stations, also built into the same modular box shape as the toilets. Efficient, standardized, and space-saving. According to renderings, SpaceX could reasonably fit 20 beds on one deck. So that's our best clue yet for how many astronauts might make the Mars journey at once, around 20 people. That makes sense when you balance the need for manpower with the limits of comfort, space, and life support. Of course, Elon Musk has famously said Starship could carry up to 100 people to Mars in one go. And sure, in theory you could cram 100 bodies in there. But in practice? That would be unbearably cramped, especially on an 8-month journey. It would be borderline inhumane. Climbing up to Deck 5, we finally get into the area where comfort starts to become a focus. The mess hall. This is the kitchen and dining area, but don't picture anything like what you're used to. Cooking in space means rehydrating freeze-dried meals using hot water and squeezing them out of pouches. It's not gourmet dining, but it's better than nothing. The good news is that astronauts on the ISS do get occasional treats, like pizza. And SpaceX could enhance this setup with a hydroponic greenhouse, growing small amounts of fresh greens to supplement the packaged meals. NASA is already testing hydroponics in space, and early signs are encouraging. Plants can grow in zero gravity, though it's not exactly easy. If it works, though, astronauts could enjoy some lettuce or herbs to spice up the menu. Fresh produce, however limited, could go a long way in boosting morale. You won't be eating tomato bruschetta, but even a few leaves of spinach or a sprig of basil would feel like a feast after months of powdered rations. And mentally, just seeing something alive and green could do wonders for people stuck in a metal tube millions of miles from Earth. Deck 6 is where we finally open things up. At this point, we've been traveling for months in cramped quarters. With a 9-meter wide fuselage, minus a bit for walls and insulation, there's actually enough room here for a lounge. This area could be a major relief from the claustrophobia of lower decks. We're talking about big windows for looking out into space, comfortable couches, large display screens, and maybe even some decorations or artwork. It might not seem essential, but trust me, mental health is everything on a mission like this. People need space to breathe, relax, and decompress. That said, don't expect 20 people to agree on what movie to watch, so group entertainment will be limited. Instead, personal VR headsets are probably the way forward. Each crew member can dive into their own virtual world, watch a film, play a game, or even simulate a walk on Earth. These systems are likely to become the most popular devices on board. But there's still a need for communal areas with actual furniture, especially for when gravity returns after landing on Mars. So we'll need chairs, couches, and tables that can function in both microgravity and Martian gravity. Climb one more deck and you'll find yourself in the workspace, Deck 7. This is where we stay productive and focused. Imagine an office in space, complete with desks, computers, and maybe even a small lab setup. We're going to be away from Earth for nearly 3 years, and boredom can be just as dangerous as a technical failure. Idle hands in deep space? That's a recipe for disaster. So having a structured environment for research, reporting, and maybe even outreach back to Earth is vital. People need a sense of purpose, and this is where they'll find it. And finally, Deck 8, the flight deck. This is the brain of the Starship, the place where the real business happens. It's where the crew will sit during launch and landing, strapped in tight to avoid being thrown around. And considering how the Starship performs its famous belly flop maneuver during descent, you'll definitely want to be up high in the nose cone to minimize the swinging motion during the shift to vertical landing. Plus, with the landing fuel now stored in the nose, the weight distribution during descent is much better. It's strategic and absolutely necessary. If all goes well and we land safely, congratulations, we're now Martians at least temporarily. The Starship itself will serve as our initial base of operations on Mars. It's not just a ride, it's home. Until we start building Elon's vision of a Martian city, this ship is where we eat, sleep, work, and live. We're not just astronauts, we're pioneers. But how we go from living in a metal tube to building an actual Martian settlement? Well, that's a story for another video.